So we've been looking at free fall. Key ideas. I will never tell you the acceleration. If we're in free fall, we know the acceleration. What's the acceleration? Negative 9.8 meters per second squared. Dropped, VI is 0. When you hit the ground, VF is not 0. That's a common mistake kids make. I can't remember if somebody said it in this class, but I always go crazy and I say something like, no, VF isn't 0. Do a belly flop onto the cement on the sidewalk. If it hurts, VF can't be 0, because if it was 0, it was you. VF, if it was 0, it wouldn't hurt to do a belly flop onto the cement, and it does. Where is VF 0? At the top for a split second sometimes. From that, there's all sorts of stuff we can calculate or predict or measure. So here we go. It says this. Ball is thrown straight up from a cliff at 12.5 meters per second, hits the ground at the base of the cliff after 8.85 seconds. So I want you to imagine, don't write this down, that we're standing on the edge of the cliff and the ball goes straight up but then falls down like that. So we leaned over the cliff in midair before we threw the ball straight up. Because somebody once said, wouldn't it just land back on top of the cliff? Let's use our imagination and stop taking our pen and do it that way. All right. What's A asking me to find? How high? Yeah, I realize how high. What variable is that from our physics equations? D. Now, we're calling it distance. Actually, it's going to give us a displacement. In fact, are we ending up above or below from where we started reading this question? I think we're going to get a negative answer. If I don't, I'll be nervous. What else do I know? 12.5, what's that?
VI.
How do you know? First of all, how do you know it's a V? Meters per second. How do you know it's VI? I think reading the grammar of the question, I think we started VI. Positive or negative? And how do you know? Yeah, Michael. What if I wanted to throw it straight down? How would you adjust that? Yeah, and I think there's one like that later on in your notes or in the homework. Okay. What's that 8.85? Time? I think I'm supposed to ask Brian that question, am I not? No, I can't remember. Was it Brian last time? I don't remember. That's only 2 things. I need 3 things to find the 4th. Oh, I know A. Now, you will see some books, because we're talking about the acceleration due to gravity, you may see some books, instead of using a lowercase a for free fall, they might use a lowercase g. I just like to use a so it matches our equation, but if you use a g and you say that g is negative 9.8, I'm fine with that too. So I'm looking for an equation that has a, vi, vf, sorry, a, vi, t, and a. Sorry, D, VI, T, and A, no VF, Mr. Dewick. Only one. Chloe, which one? Now, don't write this next bit down. Dropped, Chloe, we always said this. Are we dropped? This part here is going to take into account the distance that it traveled up. This part here is going to take into account the negative distance that it traveled down to the ball. It'll all take care of itself. We don't need to panic. The nature, physics, the equations know that, oh, you started out going up and you ended up falling down. We're going to handle that okay. We already got the D by itself, so Chloe, what's VI? T plus 0.5, negative 9.8, 8.85 squared. If you have a good calculator, hopefully I've gone on an occasional calculator rant, you should be able to type that in as is in one fell swoop. You should be able to type 12.5 times 8.85 plus 0.5 times negative 9.8 times 8.85 squared. In other words, you should be able to go 12.5 times 8.85 plus 0.5 times negative 9.8 times 8.85, and hit your x squared button. I'm hoping for a negative answer. Negative 273? Yes? So my displacement is negative 273 meters. And if you quit there, Jacqueline, I'd give you full marks. But since it's technically said height, and height is technically a scalar, I'll make a little note here. So h equals positive 273 meters high. What else can I figure out? Maximum height of the ball. So now, don't write this down. Remember my little cliff drawing? I guess we want to figure out how high it went. What variable is that going to be? Oh, d again? But probably different values that I'll be putting in. So I'm going to read dfic. I'll go d equals question mark. Now, we're talking about being right here at the top. What else do I know? Is VI still 12.5? Think so. Was it what? Sorry, what was VI? Was it 12.5? Yeah. Okay. A is still negative 9.8. Now this bugs kids. Mr. Dewick, you're moving up. How can A be negative? You're moving up, but are you speeding up or slowing down? On the way up, you're slowing down, which means you're accelerating down, which is negative. What else do I know at the top? I don't know, Mr. Dewick. I've never been at the top. Imagine for once you finished on top. Imagine for once in your life you're at the top, Brian. What else do... Oh, that came out wrong. What else do I know about the top? Yeah.
It stops for a second.
So it stops for a second is lovely English. Can you say that in physics words? You're right. I know the only time VF will be 0 is at the top. VF will never be 0 at the bottom. Don't believe me? Do a belly flop onto the cement. And if you do that in front of me and it doesn't hurt you, then I'll change my mind. But you'll have to bring me outside to the front of the school on the cement sidewalk and do a nice big belly flop and then convince me that it didn't hurt at all. Then maybe I'll listen to you. Hey folks, I'm looking for an equation with a D, a VI, a VF, and an A. There is one. Which one?
VF squared equals VI squared.
Get the D by itself, please, Misha. I'll give you a hint. D equals. That's not a hint.
D equals VF squared minus VI squared divided by 2A.
One of the things I'm also trying to build into you, Emily, is an idea of what the answer should look like. Are we above or below from where we started in this question? Folks, what do you think? Are we above or below from where we started in this question? Wow, I threw you off with that. Are we above or below from where we started in this question? Way above. Am I expecting a positive D or a negative D? If I get a negative D, I'll freak out this time. Okay? So it's going to be 0 squared minus 12.5 squared all over 2 times negative 9.8. Is this a fraction? Yeah. Is there more than one thing on the top? Yeah. Brackets around the top. Brackets around the bottom, more than one thing on the bottom. You get 7.971, that there? Or am I wrong? Nodding? Yes? Why is that wrong? Because it is wrong. Why is that not the answer? Why can't that be the answer? Brian, did you see it, or what were you going to say? Oh, I thought you were going to say something. So you ready? I'm going to draw the picture again. So we found that there. Or have we? What have we found? Let's see it. Yeah, Mateo. We have found that distance. What's the total height? That distance. What would I do with that 7.97 if I wanted to find the total height of the ball? Check some of the other things that we've just finished figuring out. Look at A, look at B. What'll I do with that 7.97? Huh? More specific. As a number. Yeah. Add the 273 to it. That's going to give me the actual height. Because we measure height from the ground, not from the cliff. That's just the convention in society. So now, plus 273 equals 200 and... what's 50, 80 something. You know what, Mr. Dewick, you got it here. Plus 273. And I'm going to get 280 point... You know what, 281. Yes? I like this question. I like this question. I like this question. It's a nice question. Well, what else could I figure out? What's the impact velocity of the ball when it hits the ground at the base of the cliff? Misha, what is the answer not? Oh, my... Folks, what is the answer not? I've been going on a rant. Huh? Not 0. It drives me crazy. Because every year on the test, I'll have somebody say, oh, it's 0. That's after it hits the base. Not when it hits the base. What's this question ask me to find? BF, you say? Brian, what else do I know? Do I know VI? What? Oh, cool. Oh, I'm in Freefall, so I know A. What? Negative 9.8. What else do I know? They gave me time. Now, if they hadn't given me time, I could use the answer from part A, the distance, but I don't like using an answer to find an answer, because if I get A wrong, I'm guaranteed to get this wrong. They gave me time? What was it, 8 point something? 8.85? Looking for an equation that has a VF, a VI, an A, and a T in it. There is one. By the way, when we hit the ground, what direction are we traveling? Down? So I'm going to ask you the same question. I'm just going to phrase it differently. Am I expecting a positive or a negative answer here? Negative, you say? So VI, 12.5 plus negative 9.8 times 8.85. Did we get a nice negative velocity hitting the ground? I hope. Oh, I missed a decimal. Do you get negative 74.2 units meters per second? Now, you could also write 74.2 meters per second down. Where I would take marks off is if you said negative down. Because technically, what is negative down? I would argue that's a double negative and it's up. So pick one or the other. Maggie, you can see which I prefer, the minus and the plus, because it's much less writing, it's clearer, and it works mathematically. Like one more we're done? Oh, 2 more we're done. And I got a couple more Freefall videos to show you too. A baseball is thrown straight up. World Series is on, seems fairly appropriate. Leaves the thrower's hand 1.6 meters above the ground. In other words, this person, when they threw it, didn't lay on the ground. They threw it from about here, 1.6 meters above the ground. More realistic. Has a velocity of 16.2 meters per second. What's A want me to find? How long? Is how long, because how long can be a distance? How long was the race? It can be a time. How long was the game? What's A want me to find? T? So, T. Are we in free fall? I know A. Negative 9.8. Right, you got notes from last day, you figure it out? What's that 16.2? VI? What's that 1.6? I don't think I'm going to use it yet. It's just telling me that we didn't start on the ground. I might have to use that. In fact, you know where I think I'm going to use that? I'm going to use it in part B, when it wants the maximum height. Because I think the maximum height, I'm going to calculate and then add 1.6 to it to get the actual maximum height above the ground. This isn't enough. I need something else. What else do I know at the top? Never been at the top. Imagine for once you finished at the top. What else? What? Here VF is 0 for a split second? Looking for an equation as a T, a VI, a VF, an A. There is one. Can you get the T by itself for me, my joy? Yes, VF equals VI plus AT. I'll give you a hint. T equals. Yes, right? Cool. By the way, time. Scalar or vector? Time is a scalar and will always be positive. I watched Star Trek once and they went back in time. No, we're going to be in the real universe. Time is going to be positive. So if you ever get a negative time, you've messed up. I get 0 minus 16.2 divided by negative 9.8. It's a fraction, brackets around the top. And I get 1.6530. I'll go 1.65 to 3 sig figs. Is that right, or am I off? Am I wrong? No. Okay. And time, what are the units for time? Seconds. Right? Right. B. What's the maximum height reached by the ball? What's this question asking me to find? D. I still know that VI was 16.2. I still know that A is negative 9.8. For a maximum height, we still know at the top that VF is 0. Hannah, which equation? VF squared equals VI squared plus 280. You have the D by itself in your head? I'll give you a hint. D equals? Good. It's going to be 0 squared minus 16.2 squared all over 2 times negative 9.8. 0 squared minus 16.2 squared all over 2 times negative 9.8. I get... May, you gonna make it? May, you alive? Wake up. 13.3 13.4? Is that right? Someone needs to give me some verbal body language feedback. Yeah? Okay. You can nod your head or something, but none of you moving. I don't know. 13.4 units meters, and that's the wrong answer. Okay, now I need to add the, what was it? How high? 1.6 meters. Total height is going to be 15 even? Is that right? Ah! Wait for it. Nothing? People on the internet right now are freaking out. I get some great comments on my YouTube channel. Wow, I had my headphones in. Well, sorry. Gotta stay awake. Gonna make it now? Feel good now? Ready to wrestle a tiger, right? Oh, you're welcome. 2 more and we're done. C, what's the final velocity when it reaches its original release point? Stop. Underline this. Then you can write, can you fill in the last word for me, please? Without doing any math, tell me exactly what V final is going to be. Not 0? Yeah. It'll hit at exactly the same speed as it left. Because whatever speed it lost with gravity slowing it down, it's traveling the same distance coming back with gravity speeding up. I mean, you could probably calculate it cleverly, but that's one that's worth just ding, 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 ding catching. Is that all right? I have one more, yeah? Is this the one I say is nasty? So far, so good? Question, Brian?
That always works.
It'll always work in a vacuum if we ignore air resistance for sure. So it'll also always work if my projectile is always like that big lead ball that I have, which is pretty aerodynamic and pretty dense. Even there, like air resistance might play a tiny part at that stage, but it would probably be in the 5th or 6th decimal. But if you're asking, will that always work if I have massive air resistance? No, and I'll prove it to you. The physics I'm teaching you does not work for a piece of paper which has massive air resistance, because watch, I'm going to throw it up. Notice how fast it leaves my hand? I don't think it came back down at the same speed as it left my hand, because air resistance does play a role. That's a great question. And so I will almost always try, in fact, I will always try and let you know when we're in our magic physics world to keep the math nice and we're close, and when we are bang on where I'm taking everything into account. It's a great point. I like example 6. I like example 6. Example 6 is a nice question. Example 6 is actually a Physics 12 question, but I'm doing it this year with you guys because my grade 12s struggled with this so much. My grade 12s wrote a Unit 1 test, and it was on what we're doing now, but in 2 dimensions. Instead of just moving up and down, we also had objects moving sideways. Projectiles. We threw them in arcs. And they really struggled. They struggled badly enough that I let them rewrite the first test. Did we get rewrites? I don't have rewrites created for you folks yet, I'm sorry. Why is this tough? Let's find out. Ball is launched straight up from the edge of an 82-meter high cliff with an initial velocity of 18 meters per second. What's this question wanting me to find? Christian, let's use our usual approach. Again, reason I always do that, Christian, just writing something down, I feel better, I'm more relaxed, I know where I'm going. What else do I know? Are we in free fall here? I know A. In grade 12, I call that our physics no-brainer. You have to know some physics, but once you realize that, it's like almost like a freebie. Christian, what's that 18? Which one? What else do I know? I gotta be fussy, by the way. If you write this, you're wrong. Because it's not a distance, it's a displacement. Are we ending up above or below from where we started? We're standing on a cliff. We're throwing it like that. Are we ending up above or below from where we started? Below. So how would I show below? No, how would I show below in what I've just written here? That's the first very common mistake. Kids miss that. And unfortunately, you're going to get weird stuff. You'll get errors on your calculator because you're going to be telling nature that you're accelerating down but ended up above from where we started. You're going to get weird things. Okay, so that's the first one. Kristen, I'm looking for an equation with a D, a VI, an A, and a T in it. There is one. What am I trying to get by itself? Why is that a problem here? Sierra, there's two of them. Now, we have done this before. I snuck this in way back here. And we, in fact, right in the first example, in the very, very first question, I think I've lost some of my work here, Mr. Dewick. Lesson 6, Freefall. Where'd the writing go? That's a little strange. Let's do this, do that, do this, and suddenly the writing is back again. Go figure. So we found how high the cliff was. We found a D. Why could we handle this one that had two T's in it? Because VI was 0, which meant that first T term canceled. That brings us all the way over to here, where again, strangely, I'm losing my words. And now they're back again. Go figure. Is VI 0 this time? Is VI 0 this time? I can't get the T by itself. It's impossible. Because there's both a T and a T squared. I've asked, but I can't remember. Anybody here grade 12? This year, in grade 11, you will do an entire unit learning how to solve this equation. This equation has a fancy name. It's called a quadratic. What makes a quadratic a quadratic? It's got a squared right there. And a linear term. You're going to have to bring out something called the quadratic formula. I'm not teaching the quadratic formula. Instead, because you haven't seen it yet, we have to do a workaround. Christian, what's this question asking me to find? What else can I find from this, though? Let's find VF. So, you see the problem with this? Okay? 2 T's. Can't solve that yet. Find VF. So now I'm looking for an equation that has A, VI, D, and VF, no T, because I don't know it. There is one. Beautiful. What is it, Christian? Although I don't quite have the VF by itself, I have a VF squared. How to get rid of a squared? Okay. So we're going to do that. Let's crunch this. We're going to get VF equals big square root of 18 squared plus 2 negative 9.8 negative 82. The 82 is negative, Joel, because we're ending up below from where I started. How would I type that in if you've got the fancy schmancy Casios with the orange buttons, you can do this easily in one step. I tend to type what's inside the square root, 18 squared plus 2 times negative 9.8 times negative 82. I would strongly, strongly encourage every one of you, yes, every one of you, try this one on your calculator, because this seems to be one that kids get wrong. And then once you get that, you're going to square root answer button. You want to see if you can get 43.94542, blah, 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 blah. And because I'm going to use this to find something else, I don't care about sig figs. I'm going to carry extra sig figs. So I'm going to go to the 0. I'm going to go 43.94542. How many got that? Okay. Okay. You're all wrong. Why must this be wrong? This is why this is a tough question. Why does this have to be the wrong answer? Mateo just did this. What do you mean by that? What? Why? What direction are we traveling here? Now here's the problem. How did we get that answer? We hit the square root button. What's the square root of 9? Or negative 3. Because negative 3 squared is also 9. What's the square root of 25? It's 5. Or negative 5. Which one does your calculator always assume you want? The positive principal root. But in math, that's fine. In physics, we have to look at our situation. I'm definitely traveling down when I hit the ground. So I have to, on my own, afterwards, add that. Seeing why this is such a tricky question, Nick? Because first of all, you can miss the negative right there. And now you're in the weeds. You're going to get all sorts of weird values. You can miss the negative right there. And that's a really tough one. Because your calculator is saying it's positive. No, it's not. It's saying the principal square root is that. But it's expecting that you know how to interpret this. Now, why is that so helpful? Don't write this down. Just watch. Christian, I know VF. I know VI. I know A. Can I find T? Is there an equation that has VF, VI, A, and T? And this lets us work our way around. We can't use the distance equation because it's got 2 T's, but I can find something else, VF. And once I have VF, I can find time. What's the equation that has a VF, a VI, an A, and a T in it? So I'm going to make a little note here. Now, use VF equals VI plus AT. Christian, get the T by itself. Beautiful. Did I say I like this question, like this question, like this question? I did. Why would I say that? Sierra, why would I say that? Did you hear me say it's going to be on the test? You notice when your teacher emphasizes certain things? Good. You're a good student. So it's going to be negative 43.94542 minus, I've scrolled down, what was the initial? 18? Squared divided by negative 9.8. Now, Rihanna, rather than typing negative 43.945, I don't know why I squared, because that's weird. Because I was doing the VF squared equals VI squared plus 2AD. A little weird. Thank you. I want to use my answer button, but I want to make it negative. How do I do that? Like this, bracket, negative, answer button. Less typing and more accurate. That's a double win. Minus 18 divided by negative 9.8. How long is it going to take this ball to hit the ground? 6.32 seconds. Whew! Now I'm going to pause for 1 second. Hannah, did I really teach you anything new during this lesson? We're just applying the 4 kinematics equations to what I think is a cool application. Freefall. Because I have jumped out of an airplane. I mentioned I jumped out of an airplane. I have jumped out of an airplane. So speaking of free fall, Mr. Duke has the video. We already watched it. I have more that I'll show you a bit later. But for now, you can do number 1. You could do number 2. What's that 350 in number 2? Mass. Does mass appear at all in our equations? No, I'm just giving you extra numbers to mess with you. I'm giving you stuff that you're not going to use. Don't need the mass. Okay, so number 2. 3 is good. I'll skip 4. 5 is good. Six is good. Before you turn the page, what's that 148.3 in number 6? Why can't it be V final? Mateo, right about now you want to start doing this. Why can't that 148.3 be the final velocity? Okay? I picked my words very carefully. I said speed. I'm expecting you to clue in, Nick. I got to make it negative 148.3. Oh, what does this word tell you? What's VI? Dropped. What does that tell you? What's VI? 0? Okay. 7 is good. Hockey puck. Let's do 8. Nine is good. I'm going to skip 10. Mm, 11 is... Wow, I'm throwing a lot of stuff at you. How much more do I have here? Okay, let me improvise here. Skip 11. 12 is good. $13 is good. Is there more questions? I can't remember. There is. So you're not going to have homework next class. We're going to watch a Mythbusters video next class. So I'm going to give you a bit more here. Let's see here. I'm going to give you 15, skip 16. $17, skip 18. $19. Wow, that's a lot. When do I see you next? Monday. And then Wednesday. Is next week Friday? Is that a Pro D day? Next week? So you got a long week. Oh, you got a really long weekend coming up because you got the Remembrance Day break as well. So I'm going to crack the whip by giving you a lot of homework today. Sorry, but I'll try and keep your long weekend free of homework. So Monday we're going to be watching a Mythbusters video. You're not going to get new homework on Monday. We're also going to be doing a little lab activity. Wednesday we'll be continuing on, but really you probably have until about Wednesday to do this in your spare time. And you got 15 minutes in class. I think a big chunk out of this. Okay? It's a lot, I know.